And here we go. So the different roles of Alexa. So please provide some interesting roles that you can heard of and you can think of by Alexa. So based on the introduction video, I would like to have some different roles from you by joining to slido.com and putting your event ID U169, right? You can put any role that you can think of that Alexa is capable of, right? So with that, we can go towards the next step, a calendar. That is correct, exactly. So Alexa can be operate as a calendar, right? We don't need separate calendars because it can remind it, right? Student assistant, browser, planning. So you can think of, there are so many roles, right? So unlike traditional softwares, how this is possible? So that is very interesting, and that is where the new era of lifestyle is heading, right? See, we have so many different roles, as you can see, very interesting roles, right? A lawyer, even a Wikipedia, right? Even Google, right? See, so very interesting. So that's where our softwares are heading towards, and that's where we need to enhance our quality. So that's the reason. So let me jump into my next slide. And now this is happening, right? How this is possible, right? So these self-learning, artificial intelligence, deep learning, and data science, all are buzzwords if we think about 2 years ago, right? But not right now, right? Everyone, even industry, knows that such systems exist, and they are always trying to inject these cutting edge technologies to their own softwares, right? Even the softwares what we are testing right now might have these capabilities as well, right? So the reason is machine learning plays a very big part here, right? I'll come to what machine learning is if you don't know, right? So that's our goal. And how this machine learning happening? So it's actually our solution training with data. So data is the key here. And once trained, then we can, like you can see in this chief, it's trained with the algorithm, and then we input the data, and with some algorithm on it, it provides predictions, right? So that's the core behind this very simple, very brief description, right? So the key points is it automatically learns with data and improve from experience and without being programmed, right? So that's the key takeaway here. So next, there are several machine learning approaches. So I'm going to big tier here, right? So that you can, it will be very easy for you to get on with the next slides. So there are several approaches, right? The supervised learning is the very first thing. It is kind of a train me approach where we need to input the data and then we can ask our model to train with the data, right? So we have regression and classification. Regression is we predicts numerical values, and classification we provides some classifying predictions, right? That's the difference. So I'll come to some examples in coming slides. So you can see here, even classification means like we can predict like male or female, like that. So then unsupervised learning. So here in unsupervised learning, the model can train without label data. Label data means, for an example, if we have mangoes and apples, the solution will be able to segregate mangoes into mangoes and apples into apple, but model don't know whether these are apples and these are mangoes. So that's it. So it can segregate based on the patterns. So that's unsupervised learning. And then reinforcement learning, that is actually some advanced level of machine learning approach where it trains from the environment. It's training continuously, right? So that is where even in production, right? Online, it's learning. Every time it's learning, and it's provide prediction. For an example, the robots, right? So that's the machine learning model in a more advanced level. But when it comes to supervised and unsupervised, we can train first and we can put that to production. So based on the trained data, it will provide predictions to the new data. right? So those are the different approaches of machine learning. Some basic approaches. There are some other like semi-supervised and semi-unsupervised like such approaches as well. But in core, these are the three approaches. Then some examples of different approaches. Like you can see in supervised learning, we have classification and regression. So in classification, we provide like male, female, true or false like predictions. For an example, image classification, identity fraud detection, like it can be true or false maybe. When it comes to regression, weather forecasting, it is a numerical value, right? And then comes to unsupervised learning, we have clustering. Clustering is the most common way of unsupervised learning, where we segregate data into different clusters. And dimensionality reduction is where we are trying to reduce the number of inputs from a total available input, right? So we use this in big data, especially. And then comes to reinforcement learning. We use this real-time decisions and game AI, as you can see here. So these are some real examples you can think of in each different approach of machine learning models or self-learning, right? Models. Then here we have some other use cases like Cortana. You can see Microsoft Voice Assistant Service. And in here you can see face detection, right? Face recognition based on the facial vectors. And here the Netflix, how they provide recommendations to their customers. So all use these self-learning capability of the softwares to achieve the outcome. And we are going to some more use cases. For an example, automation in the self-driving cars, right? And marketing, we can use this for cross-selling and upselling, where our customers can ask us to purchase new products or to upgrade existing products, right? And then healthcare is a very big industry where this capability is booming right now. And travel, sales, right? Every domain you can see such capable softwares are operating right now. Right, so that's the so you can understand how we are going to test this based on this, right? It's day by day, it's improving. So that's the takeaway here. Now I hope you got some good understanding on the introduction, right, of the machine learning. So you learned some theory, right? And now we are going to test them. So that's the most important part and our topic, right? So how we are going to test it? So I'm going to talk about what is the difference against the traditional software, right? And absence of, and test strategies, types, and some skills as a tester that you need to conduct such testing activities. Right, okay. So here another interesting question for you to vote. What is the basis to conduct testing? So from your experience, from your manual testing experience, right? You can tell it as a tester, we all know what are the basis to conduct testing. So I would like to have some answers here from our audience, and we can discuss hereafter based on the answers you provide, right? There are several basis to conduct testing, but we always there are some key facts that always we are heading towards. Exactly, the requirements, right? So requirements are the basis to conduct testing. Business domain, right? Yeah, business case, use case. So all are related to the requirements, right? So without requirements, we cannot conduct our testing, right? It's not actually quality assurance. It can be testing, but it's not quality assurance, right? So yeah, there can be test plan, and even there can be the software should available. So it should be a basis as well, but still requirements is the key part here, right? So let me jump into my next slide. So now the difference, right? So in traditional software, we have this requirement to test, right? So written logic against requirement. So human write the logic. So our developers write the logic. So we have rules in our softwares. So how we test them? So we verify the written logic against the requirement. So we tell this existence of a test oracle. So test oracle is something that we should refer to compare our actual result, right? So existence of a test oracle is there for the traditional software, right? But when it comes to machine learning systems, we don't have that exact requirement. Still, we might have the business requirement, but we don't have that exact requirement where the prediction should be like this, because that is determined by the outcome only. So upfront, we cannot say the prediction should be like this. It should be based on the trained models, right? So that's why we don't have an exact requirement to compare our actual results. So we tell that absence of a test oracle, right? So we don't have a test oracle to address this, right? So how we are going to test still? So that is very important thing that you should realize, right? So I hope you understood the difference in between two. And then we are moving to test data sets. So test data are very important and key thing, as you know, as with your experience. Test data should be there even to conduct functional testing, right? But test data is way more important as well when you are conducting machine learning model testing as well. So we have three types of data here: the training data set, validation data set, and test data set. So with these recommended percentages, you can use that. The important points are these data should not be overlapped across data sets. So it should be unique across training data set and validation. And also it should be unique test data set, right? So if overlap, our accuracy of our models is in waste, right? It should be unique. So that's the main thing that you should realize, and you should get ready your test data accordingly, right? And model training happens with training data set, and model evaluation happens with validation data set. This can be iterative. So this is mainly performing by our machine learning engineers, right? So model training and evaluation, it can be iterative, right? Once multiple iterations, we are evaluating a model, and then this is integrated into our application, handing over to QA, right? So then we are using this test data set, which is unused previously. So we use this test data set to perform our accuracy testing to the already evaluated model by our developers. So that's how we should manage our test data sets here. QA engineers do black box testing for the ML models in application level. So what does it mean? So we know black box testing is what, right? So why we do testing in application level? The reason is we are actually not testing machine learning models alone like our developers do, right? We are testing the whole applications, right? We might conduct testing, the functional testing, right? And at the same way, in application level, we are conducting machine learning model testing as well. I'll come to that, how we are going to test it, right? But you need to understand that we are doing this in application level only. Otherwise, we cannot make sure this whole integration and whole business need is fulfilled, right? So that because of that, you need to realize that we have to do black box testing for the ML models in application. That is the core. And if possible, you can go beyond that as well. You can do white box testing as well based on availability. But the minimum is that we need to do black box testing on application levels for the self-learning softwares. Now, there are some test techniques that you should know to conduct such testing. So like in traditional testing, where we have this decision trees, boundary value analysis, equivalence partition, like, right? So in machine learning models, there are different techniques that you should know to conduct such tests. So the first thing is model performance. So we are testing our model, right? The received model with the application with new data, right? Here, the performance is not like we are targeting our response times and server-side performance and all that. Here, the performance is basically the model performance, how accurate it is, right? So that's what we are targeting. So we are doing with new data every time. So this is one technique that we can use. And then we have dual coding. Dual coding is like this. So generally, our developers not using one model to fulfill a requirement. They're trying multiple models, right? Based on the evaluation, we are coming up with different accuracy levels in each. And then here we go, we are selecting one which is best for the requirement, right? So that's what dual coding is. We are trying with multiple, and we are selecting one which is best, right? In our case, in application level too, we might occur that chance as well, but it's not always, because when we receive the application, it's already evaluated, right? But still there's a technique like dual coding where we can try multiple models and select the best from by comparing the same data and by comparing the predictions of that. Then we are coming to most important test techniques, metamorphic testing. So what is metamorphic testing, which is something new, right? So metamorphic testing is that in a certain property of our application, we are targeting a certain property of that, and we are testing multiple inputs and compare each output against the original output of that. So I'll come to that, how you are going to conduct that, right? So that's the core. So we tell these metamorphic relations, and we say this a pseudo oracle, right? So because this is kind of, even though we don't have a test oracle, but this is kind of a pseudo oracle. So I'll explain why this is a pseudo oracle in the next slide, right? So that is the way that you can create at least a pseudo oracle in an event where you don't have one, right? So with metamorphic testing, you can do that, right? Now, here we have a use case, right? Build a test suite by identifying metamorphic relations, right? So use case is biometric face authentication, face unlock in your smartphone. I think every one of you is familiar with this, right? Every smartphone we have face unlock, right? So just assume that you receive such application for you to test, right? And here we go. So you need to prepare a test suite with test cases, right? To fulfill this requirement. So how we are going to build this, right? So before that, what are the environmental factors which affects the face unlock, right? It's very practical. You can think of different environmental factors which affects our face unlock. We can present the phone in front of you, and there can be different environmental factors that you can think of, right? Exactly, light. So it's very prime factor, right? You should have good lighting conditions to successfully authenticate your phone, right? Otherwise, if your face is not visible, phone will not get authenticated, right? Quality of the camera or sensors, exactly, right? It's again an environment factor too, right? Distance, right? Distance also, wearables like sunglasses, caps, right? So all are different factors. So all are certain properties that affects the successful face unlock, right? So I hope you understood what are these environmental factors, right? So distance, light, and all are very good answers, right? So with that, we are going to next slide. So example test cases, right? So how we are going to identify a test suite. So I pick distance as my property here, right? I'm going to input distance with various distances, right? So I'm going to draft my test cases here. So it's like this. My first test case is I'm picking a certain distance, like 25 inches, right? And then my output is I'll put like likelihood estimates as y. So y is kind of 0.75 in a model prediction where it predicts from 0 to 1, right? Our face unlock. 1 is more successful, right? 0 is in a negative side. So 0.75 is the likelihood estimate, right? So model predicts this result in between 0 and 1, right? So I write this my first test case. If the distance is 25 inches, my face is 25 inches from my smartphone, right? Then my prediction, my application prediction will be 0.75%, right? Then here we go with the next test case. So if the distance is increased, ultimately you know the likelihood of a successful prediction is less, right? So we are writing test cases like this. If the distance is 35, the value of y2, the new output, should be less than the previous y1, right? Because in y1 we had 25 inches, and if we had 35 and 45, it still should be less than y1, right? So that's how we should write test cases when we are building such test suites, because we don't know exact output in this case. Unlike traditional softwares, we do have exact output that we can, by looking at the requirement, we can derive our test cases, right? But here we have to come up with a pseudo-oracle like this, right? So if we have a 15-inch like that, so it should be greater than Y1, right? But still you need to find out the breakpoint, like if a phase is more closer, then it will not get authenticated. Those are kind of functional test cases as well, right? So this is how, so this is a metamorphic relation. So you have an input as distance and output as likelihood the phase is authenticated, right? So this is a metamorphic relation. So like that, you can build all your test suits, test cases, and build a test suit. So you need to think about all the environmental factors and cover your test coverage, right? Achieve your test coverage. So that is how we should build our test suits, targeting our self-learning software, the self-learning ability, machine learning ability, right? The prediction. Okay, excellent. So I hope you got some good practical experience with this use case. And with that, I'm going to different test types. So accuracy is the main thing that we should concern on in machine learning models, right? So that is the key thing here. So based on the accurate, only our software is getting successful, right? And then data and feature quality. In more of a data science related models, we need to concern about the data, and even machine learning models, we need to concern about the data, because data can be fooled, right? It can be, there can be false data. So we need to verify our data, what we are using to train, test, and evaluate all compliant data to our requirement, right? And features in more of a data science context, right? In features, we need to assess the feature quality like compliance, and we need to see whether all our features are necessary for our prediction or not. So all these things we need to think about when testing. And efficiency performance is pretty straightforward. We need to see our resource consumption and response time during the load, the performance of our software, and portability, the model operation, right? And in different browsers, right? Deployability, easily installable and deployable, because deployability is also something that our testers not really think of, but still, because this is something DevOps do, right? But still, this is something you should worry about, especially on self-learning software where machine learning models are exist, because those are very huge in size, and deployment can be hours, right? Due to that, as a tester, you can provide proper suggestions to your engineering team by sharing your recommendations to them for a very smooth deployment. Fairness. So this is something new for us, which is not in traditional softwares. So bias and variance trade-off. So what is bias? So we have this trained machine learning model, right? So bias is average prediction percentage out of actual percentage, right? So by comparing the average prediction of all in the test and with the actual one, you can get this bias, right? Variance is a bit different. So variance is that we the difference between our trained data average prediction and our new test data average prediction. So always there is a bias and variance trade-off. So that is always there in these models. So if bias is low, variance could be high. If variance is low, bias could be high. So low bias, low variance machine learning model is the ultimate goal of every architect engineer. But low bias, low variance machine learning models are very hard to achieve. So always you need to find a good balance in this, right? So you can assess the fairness when you are doing the accuracy testing. So I'll come to some evaluation methods how you do accuracy testing in coming slide. So fairness, you can assess this fairness in your testing, and you can suggest, you can put recommendations to your engineering team, right? Then security. So adversarial machine learning is something very rapidly growing right now. That is that live softwares can be fooled with data, right? So you need to be careful when you have online self-learning softwares operating. This fault data can be injected to your softwares and it can be corrupted, and it is kind of, we are losing the availability of in production, right? So you need to consider security aspects of machine learning models in that way as well. And then reliability, the probability of failure-free operation with some longevity runs and all. So these are some test types that you can think of. And you can cover each in your test suits. Then only we can satisfy that we come to some expectable way where our testing coverage is good, right? Now we are going to the last part of our presentation, the evaluation. So I picked 3 models here, the 3 most common models we can industry is using right now: the classification models, regression models, which predicts numerical predictions, and object detection models, right? So because the thing is now evaluation have to be unique to each type. So that is why the importance of knowing different machine learning models by you. So the software that you are using and you are going to test, you should know what kind of model you have, because with that, your evaluation techniques are different, right? So first thing is classification models. So for classification model evaluation, we use confusion matrix. As you can see, we have binary classification here. We have only 2, right? Positive and negative. So this is kind of a very simple table where you can put actual values and predicted values, and you will come up with your accuracy testing, you will fill this confusion matrix, and you can come to some certain metrics like this: precision, recall, accuracy metrics. So you can get to know about these metrics in Google, right? What are these and how you, it is very easy. If you can fill out these confusion metrics based on the result in your testing, you can come up with these metrics and you can present to the project team, right? With that, there are some other advanced metrics as well. For an example, F1 score. So with that, you can identify a good balance. Your engineering team will be able to identify good balance and where this model is currently stands in terms of accuracy, right? When it comes to multi-class classification, like our prediction provides more than 2 classes, right? Then these confusion metrics become bit complex based on the number of predictions. The binary classification is the most simple one, right? So still you can use the confusion matrix to come up with the accuracy, right? Then the regression models, where it predicts numerical values, right? We are identifying the residual error of that. So for an example, in this graph, you can see this linear equation. You can see the predicted values here. So the difference between the actual and predicted is the residual error, right? You can calculate the residual error and you can come up with mean absolute error and mean squared error, root mean squared error, right? Like metrics. Again, you can, I'm not going to describe here since we are in time boxing, right? So you can get to know, so different metrics, right? From classification model to regression, right? So mean absolute error like this. So it can be simply without the direction, without the positive or the negative, you are getting the difference of these each and get the average like that. So very simple things, right? But by correctly evaluating, you can present this to the your engineering, which is very important when you're evaluating the machine learning models, right? Then we are moving to object detection models. So in object detection models, we are detecting different objects. So we having this intersection of a union. So as you can see here, we are trying to detect the stop sign. And this green box is the ground truth bounding box, which is the actual boundary of this object, right? But our solution, our software predicting slightly offset, right? It's the red box is predicted bounding box. So we are getting the area of overlap and we are getting the intersection of a union. So if this is more than 0.5, generally we are saying that our machine learning models are detecting objects well. So if this is below than that, then it's not right. So these are different evaluation techniques you can use to each machine learning model type. So hope you got some very good context here. Then the skills needed for testing ML models, right? So the quality assurance basic thing is must, as we all know, right? In addition, you need to have some some introductory knowledge of machine learning concepts, like I mentioned, the different types of the model, so that at least by discussing with your development team, you can get to know what kind of model I am going to test, right? That questions you can ask and clarify. Right? Then you can dig deep and search on how should I evaluate such models, starting with the ones that I mentioned, right? And knowledge of terminologies related to this context itself, like features, bias, variance, right? Like that. And then the different metrics like precision, recall accuracy, what is the meaning of this, right? You can get to know, you can dig deep and get some understanding on this before you're testing, right? And general data analytical skills and scripting knowledge will be some plus things. So with this, you will be able to conduct machine learning model testing, which is existing, I mean, self-learning softwares testing with these evaluation models. So, right. So in the future, we may train our computers, phones, and wearables instead of downloading applications and changing settings, right? So that is a very big thing, right? I mean, you might not install different applications for your different tasks, right? In future, it can be one operating system, maybe it can be one software. It will learn with you over time, right? You don't need to download different softwares for different tasks, right? So are you ready to test this? So in few years time, maybe we don't know actually when will this happen, but still our industry is going towards that. Based on the increased capability of the hardware, right? We are going towards this. So as testers, you need to be ready on this, right? Because in future, you might not always testing your functional pieces and automate that and done with it. You need to plan the such machine learning model testing, like the self-learning softwares, testing differently, and you might have a different machine learning model accuracy test suite with your functional test suite, right? So that's how you have to plan in future in such applications, right? Okay, thank you. So to sum up, we discussed about the theory part, high-level theory about the self-learning softwares, right? Then we jumped into different testing, how we are going to test it, and different techniques and skills and different testing types that you should cover. And then we finally understood different evaluation techniques for each different model types. So thank you very much. And Chatura, over to you.
Yeah, we have two questions.
Sure.
Can you explain?
Yes. So the first question is, how do you diversify the new data for the model? So do we, right. Do we have a rule of thumb? So yeah. So how do you diversify the new data for this? So that is basically when we are identifying the data in the beginning, like the analysis and design phase, right? So with the development, with the project management, first you need to pick these are the trained data. So it'll be overall, it will be a one pool of data. Then you need to have this different percentages, what I mentioned there, with the understanding of developers, with a common understanding. See, this is the portion of new data. The test data, don't pick this. This is not available for development and training and evaluation, right? So the training, this data can be generalized, right? So you should pick the correct data. So that is a very important thing. But when you are segregating the data to training, evaluation, and test, so it should be done with the common understanding that these data are not available for training and evaluation, but only testing. And even test data, you can have a few sets, right? Because with one test data set, you can't complete it. So you need to have few in between that 15% of all data. You should have different multiple sets as well. With that, you can do multiple rounds of testing. Yeah. So I hope you understood the answer, right? And the next one, I'm currently testing with Alexa integration. Excellent. So what is the better way to do it? And is there any specific test tool available? Okay. So now Alexa integration is something that now with Alexa integration, you will be able to get the size of it, right? So then when you are testing again, like I mentioned, it will be with the application level, right? Because there are some testing tools available, like in development, like OpenVINO, TensorRT for training, right? For inference, right? Model inference. Model inference means we are training the existing, already learned capabilities with new data. So after integration, it's a matter of inputting different commands based on the whole. If you are not, if you are not implementing a new skill with the already available skill set, you can identify new pool of coverage and test it. So again, it's down to different the types that I mentioned, and also the different machine learning model types. So that you need to dig dig deep and identify what is the mechanism behind that. So in terms of test tool, we don't have separate test tools for this activity, right? It's again, you can even do manually as well. If you are come up with this confusion matrix or residual error chart, right? Based on the each test case output, you can draw it and come up with a matrix. So that's easy as that. So how do you test residual and graphs with tools? Yeah, tools are there, right? So even with tools, residual is like this. You can have the prediction and with the overtime the test cases in the horizontal axis. So then you can plot it manually, or if we have tools, actually I didn't try such tools right now. Because as I mentioned earlier, we don't have any separate test tools for this activity, but you can talk to your developers and see what level of tools they are using, and you can get some understanding on that as well. Otherwise, it's just a matter of creating a table and plotting a chart, right? Right, we have another question. How do we test the performance of machine learning? Hold on. Yeah, I hope your question is how we test the performance of machine learning.
Yeah, there is one other thing, and the question is, can you explain the use case diagram in slides? Maybe it's 9 slides or somewhere near that.
Okay, let me jump into that. Not 9th slide. I think it should be 8th, right?
Yes,
No.
use
Will
case.
this be your Chatur? I think use case is this one.
The question is on use case diagram.
I think this is it, right?
Yeah.
Can I check the question?
It's at,
right, you can see it, yeah. Okay, 9, 10, 11 again. Right. I think this is the approach of a general high-level approach of a machine learning model, right? So first we are training, right, with the trained data, as I mentioned earlier, and we are getting the trained data first, and then we are trained the machine learning algorithm, right? Then we do machine learning inferencing. We have already learned capabilities. We are testing it, right, with the new data, right? Then we are getting the prediction. So that is the high level flow of our machine learning model testing, right? Chatur, I hope I answered the question. So that's it on it.
Yeah, okay, no worries. So
Right.
anyone else having any questions? Yeah, maybe that's all for questions.
Okay.
So Chandima, indeed, you are an exceptional, no arguments with that, because you try to touch all the possible areas in software testing, which normally normal software testers not even think about, and it's really wonderful. And also you bundle everything into one piece within 1 hour, and that is also a really challenging goal. And thank you very much for doing all this wonderful knowledge sharing. And also you make more interactable this session with Slido. I think it adds more energy to the session. So I think now all of you might have some kind of understanding on self-learning software testing, or at least some understanding on some of the topics Chandima tried to touch during his session. I am pretty sure that this will definitely help you to build a better career as a software test engineer. And please try to apply these things on your daily projects or your daily activities. Finally, thank you very much for the participating today's session with your busy Monday evening schedules. And again, Chandima, thanks for your valuable time also. And
Yes, Chatura. Actually, this one question we have, Mahesh is asking, how do we do the performance testing of ML models?
yeah, go
So,
ahead.
this is about now accuracy testing is separate thing, and when you measure in the performance, you can from the in technical terms from backend you can perform the response time of your machine learning model output, right? So in that, because since we are doing the testing in application level, by alone you cannot assess the performance, right? So still you will do the application level performance testing with that, with some kind of a monitoring tool like New Relic or ELK, right? With logs, you can assess the response time of this. What is the start at timestamp and what is the end timestamp for your machine learning model output, and you can assess the response time. So with that, you can assess the performance of machine learning models. And mostly in CPU environments, it's not in production environments. CPU computers will not do such processing. It will be always GPU machines. So I hope, Mahesh, you got some context. So please reach out to me if you have any questions, and the rest of the audience as well. Okay, Chatur.
Yeah, I think that's a really good question, and the questions means that the audience had some kind of understanding on your topic and your ideas. So that's really
Yes.
good. And so we'll meet again with another interesting topic, maybe in mid-February. So till then, stay healthy and stay safe. Thank you, guys. Thank you all.
Thank you, guys.